So now I'm going to have a go at the next exercise in lesson 14 of Codility. It's called Nailing Planks, and it's in the binary search algorithm section. Okay, you're given two non-empty arrays A and B consisting of n integers. These arrays represent n planks. More precisely, AK is the start and BK is the end of the kth plank. Next, you're given a non-empty array C consisting of m integers. This array represents m nails. More precisely, Ci is the position where you can hammer the ith nail. We say that a plank, AKBK, is nailed if there exists a nail, Ci, such that AK is less than or equal to Ci, which is less than or equal to BK. The goal is to find the number of nails that must be used until all the planks are nailed. In other words, you should find the value j such that all planks will be nailed after using only the first j nails. More precisely, for every plank AKBK such that 0 is less than or equal to k, which is less than n, there should exist a nail Ci such that I is less than j and AK is less than or equal to Ci is less than or equal to BK. Okay, so for example, given this example here, 4 planks are represented by 1, 4, 4, 5, 5, 9 and 8, 10. Given the array C such that C is like this, if we use the following nails, 0, which is position 4, planks 1, 4 and 4, 5 will both be nailed. If we use 0 and 1, 4 and 6, 1, 4, 4, 5 and 5, 9 will be nailed. 0, 1, 2, 4, 6, 7, the same will be nailed. 0, 1, 2, 3, all 4 planks will be nailed. So 4 is the minimum number of nails used sequentially that allow the planks to be nailed. Okay, write a function given the arrays returns the minimum number of nails that allow all planks to be nailed. If it's not possible to nail all the planks, the function should return -1. So given that example, we should return 4. Write an efficient algorithm for the following assumptions. N and M are integers between 1 and 30,000. So N is the number of planks and M is the number of nails. Each element of array A, B and C is an integer within the range of 1 and 2m. Okay, so we don't need to worry about overflowing integers because 2m will be a maximum of 60,000, and AK is less than or equal to BK, so we don't need to worry about A being larger than B. Okay, so the first thing I'm going to do is set up my class with the numbers in the example. Okay, so the first thing I'm going to do is create a class to represent a nail. So make class nail, and in that class I'm going to have the index and the value of the nail. I'll just create a constructor so that I can create them quickly. And I'll create a toString method because I'll probably be debugging and checking what's happening by looking at the debug string. Now I'm going to want to sort these nails, and I'm going to want to sort them by value because I'm planning to do a binary search on the nails that can hit the planks. and I want to find a nail, but it's really the index we're going to be looking for, but I want to find the nail by its value. So I'm going to make the nail comparable with another nail, and in the compare to method I'm going to compare its value with the other nail's value, so that will enable us to be able to sort our nails by value. Okay, so I'm just going to start by creating a list of nails. And the nails are defined in C, so I'm going to go through the C array, and I'm going to say nails, add new nail, the index is I as I'm looping through the for loop, and the value of the nail is the value in C. Now I suppose I could do an optimization here, because if we have two nails in the same position, it's only going to be the first one that we want. The reason it's going to be the first one is because that one's at the first index. So for example, if we had a nail 4, 6, 4, 10, 2, that second 4 would not be useful at all, because we've already got a nail at position 4. So what I'm going to do is just make a set of integers, nails seen equals new hash set, and here I'm going to say if not nails seen contains C at I, which is the value of our nail, then we'll add it to our nails array, and I'll also add it to nails seen. So if we have seen the nail before, we're going to ignore it. And then finally collections.sort nails. I'm just going to turn -1. I'm going to debug this as I go through, because there's quite a few steps to this problem. So I'm going to debug it so far. Right, so our nails are 4, 6, 7, 10 and 2, and the index 0, 1, 2, 3 and 4. We want them in order, so we want to see 2, 4, 6, 7, 10. So we add nail 0, 4, index 0, value 4, 1, 6. Add them all. 0, 4, 1, 6, 2, 7, 3, 10, 4, 2, and then we sort them, and 4, 2, 0, 4, 1, 6, 2, 7, 3, 10. Okay, so they're in order of value, but we also have the index. Actually, I think because we're counting how many nails we need, I think I'll make the index I plus 1. So 5 is at position 2 in the array. Sorry, 2 is at position 5, sorry, in the array. 2 at position 5, 4 at position 2, 4 at position 1 rather. Okay, so that's our first step. Now I'm going to make a class to represent our plank, And I'm going to do a similar thing to the planks. So I'll just make a plank class. And that's going to have a start position and an end position. I'll add the constructor. And I'll add a toString method. And I'm also going to make that comparable to other planks. And the plan here is I'm going to sort my planks by start position. And the reason I'm going to do that is because I want the start position to increase as I go along. And the end position, if one plank can contain completely another plank. So for example, if we've got a plank which goes from position 1 to 10, then we have another plank that goes from 2 to 5. The plank from 1 to 10 can be removed because it completely contains the plank from 2 to 5. And the minimum value that we can hit 2 to 5 from is definitely going to be less than or equal to the minimum value that we can hit the plank at 1 to 10. So the way I'm going to do that is sort my planks. So I'm going to sort them by start position. So I'm going to sort the comparable method to be start compared with the other start. And then I'm going to create my planks array, list a plank. Is this an A length? I++. And I'm just going to add all my planks for now. And the plank goes from A at I to B at I. Now collections.sort planks. So what I'm going to do now is I'm going to loop through the planks, and if the plank before it ends after the end of the plank that we're looking at, I'm going to remove the plank before it, and I'm going to keep removing planks before it until the plank before it ends before it. So I'm going to go to plank size -2 because I'm going to look at the one ahead. I'm going to say if planks at I end is greater than planks at I+1 end, then I want to remove planks at I and subtract 1 from I. And I want to keep doing that, so I want to while that until we've got to say, well, I is greater than 0, otherwise we'll have a index out of bounds. So what I'm saying is any plank before another plank that ends after this plank ends, we know it starts before, so if it ends after, we remove it because it completely contains this plank. Okay, so that's an optimization. So we've got rid of any nails we don't need, we've got rid of any planks we don't need. Okay, now I'm going to loop through the planks. and I'm going to do a binary search to find the minimum index of a nail. So int min index equals get min nail index for the plank. And if the answer, this method I'm still going to write, but if I'll return -1 from this method if we don't have a nail that can hit that plank. So if min index equals -1, then we'll return -1, because if we can't hit any plank, then we've failed. And then I need to say max min, I'll start off at 0, and max min should be the maximum value of what it currently is, and min index, and then the answer is max min. So just need to write this method, and this method is going to do a binary search. So public int get min nail index, and it's going to take a plank. So for the binary search, we set start and we set end, and the end should be the number of nails that we've got. I need to pass this and nails. So our end index is size -1. I'm going to say while start is less than or equal to end. Our center position is start plus end over 2. And then I want to say if nails at the center position, we know that these, so the nails are sorted by value, we did that before. So if the value is less than plank start, then we want to look later than this, so we want to move our start position to center +1. Else, if our nails at the center position value is greater than plank end, then our end position is center -1. And then else, now I want to go to the start of the, if there's several nails that can hit the plank, we want the first one. So this is a valid result. So here I'm going to say int result. I'm going to start off as -1, but this is a valid result. So result equals center, but we want to carry on searching sooner if we can. So we want that value to give us the first nail that can hit our plank. Now the first nail that can hit our plank is not necessarily the best one, because there may be one a later value with an index sooner. So at this point, well, right now I'm going to say if result is -1, then we don't have a plank that hits the nail. So we return -1, and that's going to exit completely with the answer of -1, which is invalid. But now I want to go from this now. First, I've got the min index, that is the nails at the center result, sorry, the nails at the result, the index of that. But now I want to loop from result +1. I don't want to go out of the number of nails that I've got, I++, and if nails at this index value is still less than or equal to plank, and so if this nail is still okay, then min index needs to be the minimum of what it currently is, and this nail's index else we found our min index. So what I'm doing there is we know the nails are in order. We may have a nail that hits the plank, but the minimum that hit the plank is not necessarily the first one we hammered in. So we're going to loop through all of the ones that hit the plank and find the minimum index of them. And that is it. If we don't do anything in this loop, we've got our minimum index from there. So is that it? So let me just run that. We got the answer 4, 1, 2, 3, 4, which seems to be correct, but I'm just going to debug through it again and explain what's happening. So we have our nails 4, 6, 7, 10 and 2. We save them into an array, and we have nail at index 5 was 2, nail at index 1 was 4, nail at index 2 is 6, and the index here is starting from 1. Nail at index 3 is 7, and nail at index 4 is 10. So the index is starting from 1, so we have 1 to 5 because we're counting the number of nails we can hammer in, and these are ordered by value 2, 4, 6, 7, 10. We then make our planks. We have 4 planks in this example. They are from 1 to 4, 4 to 5, 5 to 9 and 8 to 10. We sort them, and in this example they stay in the same order: 1, 4, 4, 5, 5, 9, 8, 10. Now we will remove any planks. They're ordered by start position. If the end position of 1 goes past the end position of a later one, we will remove it. In this case we're not removing any, but we're doing that because a smaller plank completely contained by a larger plank means the larger plank can be taken out. So our maximum min value, so for each plank we get the minimum nail index. So I'm going to go into that for this one. So there's our nails, and our plank is from 1 to 4. So we start at considering a range of nails from 0 to 4, which is all the nails. We go with a result of -1 for now. Start is less than end, which is true, and this is a binary search, so the center is 2. We'll look at the nails at the center. Nails at position 2 is 6. Our plank starts at 1 and ends at 4, so that is going to fail, but this is going to succeed. So the nail is beyond the end of the plank, so we move the end back to position 1. We know that the nail we want is either at position 0 or 1. So start is 0, end is 1. Center, doesn't matter what it picked, but it picked 0. Nail's at position 0, value is 2. That's going to hit the plank. So we'll keep that, but we want the first one if we can. So we move down, but now start is 0 and end is -1, so we've got the nail we want. Result is 0. If result was -1 here, we would return -1. And the minimum index, so we're going to start at the nail at position 0, which has a value of 2. Now the plank goes from 1 to 4, so the nails that would hit it will be that with a value of 2, that with a value of 4, and the next nail with a value of 6 will miss it. So min index is 5 because this nail hits it, and then we go from the next nail. That one will also hit it, but this one has an index of 1, and that's the one that we're going to want to hit it with. The next nail will miss it, so we return the minimum index, which is 1. Minimum index is not equal to -1. If it was, we would completely miss that plank and exit, and the minimum max value is now going to be 1. The next plank goes from 4 to 5. We're going to want to, well, we're looking at this list, 4 to 5. We're going to want to hit that with now 1. So just see what comes out of that method. 1, which is correct. The next plank from 5 to 9, going to want to hit that with now 2. 2. So the minimum number of nails we need is now 2. The next plank from 8 to 10, we're going to want to hit that with now 4. And 4, and that's our answer because we've run out of planks. Okay, so I'm going to submit that and see if it works. And 100%. So that is quite a tricky one there, but using the binary search, well, the clue is in the question really, because it's in the binary search section. It did try some nails in the same place, so I think it was a good idea to remove duplicate nails, and it's done some large planks, 30,000 long arrays and that sort of thing. So I'm quite happy with that, and thanks for watching.